Here is the outline for question 7. Part A. Find the two square roots of 1 minus 2 root 6i. Give exact answers in the form x plus iy. Part B. Shade the region where modulus z minus 3i is at most 2, and find the greatest argument of z in that region. Let's start with Part A, finding square roots. Part A, the method for finding square roots. Let the square root equal a plus bi, then square both sides. Let the unknown root be a plus bi, square it, and equate real and imaginary parts to get two equations. Step 1. Let the square root equal a plus bi. The root is a plus bi, where a and b are real numbers. Separate a line. Step 2. Square both sides and expand. Expand a plus bi squared, then equate with 1 minus 2 root 6i. Squaring gives a squared minus b squared plus 2abi equals 1 minus 2 root 6i. Separate a line. Step 3. Equate real and imaginary parts. Real part, a squared minus b squared equals 1. Imaginary part, ab equals minus root 6. We now have two equations to solve simultaneously. Part A. Solve the simultaneous equations a squared minus b squared equals 1, and ab equals minus root 6. Recall equations 1 and 2. Substitute b equals minus root 6 over a into equation 1. Substitute b into equation 1. Substitute, simplify, multiply by a squared, and rearrange to get a quartic in A. Let u equal a squared. The quartic becomes a quadratic in U. Solve as a quadratic in U equals a squared. Factor to get U equals 3 or minus 2. Reject U equals minus 2, a squared equals 3, so A is plus or minus root 3. Find b from ab equals minus root 6 for each value of a. Find b using ab equals minus root 6. When A is root 3, b is minus root 2. When A is minus root 3, b is plus root 2. Separate a line. The two exact square roots are root 3 minus root 2i and minus root 3 plus root 2i. Box the final answers. Part A answers confirmed. Part A verification. Square each root and confirm you get 1 minus 2 root 6i. Always verify by squaring your answer back. Check root 1, root 3 minus root 2i, squared. Expand and simplify. Remember I squared equals minus 1. 2i squared becomes minus 2. Simplify to 1 minus 2 root 6i check mark. Separate a line. Check root 2, minus root 3 plus root 2i, squared. The second root also squares to 1 minus 2 root 6i. Both roots confirmed. They are negatives of each other. Moving on to Part B. Part B. Understand the region where modulus z minus 3i is at most 2, and find the greatest argument of z. Split the screen into two columns. Left column, the region. Modulus z minus 3i is the distance from z to 3i. At most 2 means a filled disk centered at 3i with radius 2. The region is a closed disk centered at 3i with radius 2. Right column, greatest argument of z. Greatest argument is the angle to the left tangent from the origin. The origin is outside the disk, so a tangent exists. Sine alpha equals r over OC, which is 2/3. Greatest argument is pi over 2 plus arcsin 2/3. Argument of OC is pi over 2, since C equals 3i on the positive imaginary axis. Now draw the Argand diagram. Part B. Argand diagram. Shade the disk and draw the tangent from the origin for greatest argument. Draw the Argand plane with axes and tick labels. Shade the disk centered at 3i with radius 2. Mark center C at 3i and origin O. Draw the radius and label it R equals 2. The disk includes its boundary. Replace the disk tip with OC information. Draw OC modulus OC equals 3, greater than radius 2. The origin is outside the disk. Mark argument of OC as pi over 2. Pause on the geometry. Replace with tangent construction tips. Draw the tangent from O to tangent point T on the left. Draw radius CT perpendicular to the tangent. Right angle marker at T. Tangent length OT equals √5. Mark angle alpha between OC and the tangent. Mark the greatest argument from the positive real axis to OT. Review the angle arcs. Replace with the working panel. Greatest argument equals pi over 2 plus arcsin 2/3, about 2.3 radians or 131.8 degrees. Part B answer complete. Full summary for question 7. Part A. Roots √3 minus √2i and minus √3 plus √2i. Part B. Greatest argument pi over 2 plus arcsin 2/3. End of question 7. Fade out.